Good evening, folks. Today I would like to talk to you about twist drills, or drills in general. As you can see in front of you, or on the screen, there's a rather large quantity of drills. I'll start with these at the back here. Now this is, I thought, marvellous. All the drills I need in one box, great. Only trouble with them is they're absolute shit quality. I paid good money for these, but they just don't last. They are high speed steel, but they just don't take any punishment. And in the end, especially when I got the CNC machine, I thought I need some drills that will take punishment, and I bought these. Got these from Cutwell. They weren't cheap. I think they were about close to £100 for that set there, but they're very hard. There's a few missing, not many. Most of the ones that are missing are actually set up in chucks for various operations. This lot here I still use occasionally in the hope that I might be able to drill a hole with them, but usually I give up and go back to these. And these here are also a good quality set, which I bought from a local tool dealers, but they seem to be pretty good. One or two broken ones there, but they're quite small. They're number drills, 0 to 60, and they also go from 60 to 80 in a smaller box, which I believe up here. Similar sort of arrangement. Stupid box, they all fell out, and you can see they're pretty small. You'd be lucky to be able to focus on that, but that's pretty small. Not the sort of thing you want to be using in anger. So they're number drills. They're an old, like, wire gauge sizes. These are metric, 2 to 10, and these are imperial, as you can see there, in 64ths up to 1/2 inch from 1/16 of an inch. Again, number drills, 0 to 60 or 1 to 60. Higher the number, the smaller the drill. And these are letter drills. These were some kind of weird British standard. Again, I think a lot of them were tied in with their plate sizes and gauges. And also, the odd large hole you need to drill. This is a blacksmith's drill. I don't know why they're called blacksmith's drill, but the reason I use them is they're good for opening a hole out on the lathe, for instance, so that you can start boring from a decent size, and they also fit in a 1/2 inch chuck. And the biggest chuck I've got takes 5/8. Now these are also drills. I bet you haven't seen these before. You might have if you're a model engineer, but these are what's known as D-bits. I don't know if you can see the shape of the end. They're known as D-bits because of the shape of the end, like a letter D. Basically, they're pieces of high carbon steel, which is heat treated, or these ones are actually high speed steel, ground down to half the diameter, and then the ends are ground with a slight angle to one side. And you can actually drill, these will drill a very accurate and very good finish hole, but they don't, they don't keep their edge very well. This one here is a homemade one, as you can see. I do make the odd tools now and again. This was it was actually used as a reamer for a cone shape, a conical hole, a tapered hole for a blast pipe in the chimney of a model locomotive. So that's the drills that I'll be covering, well, that I use, and I'll show you how I go about sharpening drills as we progress. Okay, now then, here you can see the tip of a drill. Now then, if you look here, the cutting edge is on this side, the lower side here, because the drill will rotate in that direction if it's a right hand drill. And it's got two teeth, that one there and that one there. Now the way they are ground, if I bring it round into here, you can see there, that is the relief at the back, and if it's very hard to get it into focus, but you can just see there where the two different angles. You can see the edge, the long sloping crescent shaped part is the relief, and that is the ground part there that produces the tooth, if you like. Same on the other side. There you go. So that's what you aim to get. Now, if I show you a drill that is completely knackered, this is probably how a lot of your drills end up. Look at the shape of that. And this is caused by work hardening phenomena, which is very frustrating, especially if you're using certain materials like stainless steel. If you drill a hole in stainless steel, get the drill going and don't stop. Just keep putting the pressure on. If you let up, it will work harden on you, and it'll just turn the drill will. You think it's drilling away, but it's not. It's turning red hot, and you're wearing the drill away, and you're making the material harder and harder that you're trying to drill. So the only cure for that is usually a solid carbide drill, which is an expensive piece of equipment. So what I'll try to do is try and show you how I hand grind these drills. Okay, so I've got the camera focused on the grinder here, and I'm going to try and grind this drill that we had earlier that I showed you. I'm going to try and grind that so it drills something. Okay, so here we go. Well, you can see there I've got it roughly about the correct angle. The bigger the drill, the easier it is to actually grind these. However, it doesn't look right. I'm going to take another look at that, and in fact I can see why it's not right, because I haven't ground it far enough. Here it's still worn at this edge. I don't know if I can focus on that. Probably not. That side's not too bad, but again, looking at the angle is actually down over. If I were to put that in the metal at the moment, it would actually, it wouldn't cut at all. But anyway, the main thing is here I've got roughly the shape I want. Now then, I'll go back to it, and I'll try and improve it and show you exactly what I'm after here. Now then, that looks pretty good there now. As you can see that part there, it's very hard, that part there is the cutting edge, and that part is the relief at the back on that side, and again that side there is the cutting edge, and there's the relief on there. The relief on this side isn't quite as big as it is on the other, but we'll give it a try and we'll see if it'll drill a hole. Okay, now a test of how good a drill is if you've ground it right, it should produce 2 spirals, one from each of the cutting blades. Now I'll guarantee you that won't happen with this one because I'm not that good at grinding, but let's have a look and see. We'll make it easy, we're drilling some aluminium. There you go, hole drilled through there. It did actually produce 2 spirals, one from each teeth, each side of the drill, each of the flanks. However, that was probably because I was piling the pressure on and cutting through that fairly quickly. If it had been in steel, it probably wouldn't have happened. Now then, that's good. I mean, that drill's sharp enough to use. But the one thing you can almost certainly guarantee once you have actually reground a drill is it's going to drill bigger than it should. Because you get the flanks uneven, the centre of the drill, let me just put this down where we can see what we're doing. Okay, because when you grind a drill, one side may be slightly longer than the other, which then means that the drill is off centre and it'll drill a hole the same diameter as 2 times the length, in other words the radius of the longest flank, and it will actually produce too large a hole. Now I can check that. I'll check it on the hole that I've just drilled. Okay, well, here we are. Here's hoping you can see this. This drill is 10.41 OD. It's actually meant to be 10.5, but most twist drills are just a very slight bit undersize because I have a habit of drilling oversize. And if I measure the hole that this drill bit has drilled, it's actually reading 10.62, so, well, 10.7, and you know, that's quite a bit over. It's amazing how much they will actually, I see 10.72 as against 10.42. That's 0.3 of a millimetre, which is quite a bit of clearance if you, or quite a large difference. So it just shows you, just because you resharpen your drill and it drills a hole, it doesn't drill, it won't necessarily drill the hole size that it says the drill is. That's what I'm trying to say. Of course, if you want to retain accuracy, and I'll be quite honest with you, drilled holes, yeah, they're there solely for that purpose. Just put a hole in. If you want accurate holes, you bore them out or you ream them. Well, here we've got another blunt drill. I seem to have quite a few of them actually. You'd think with all this equipment around I would have quite sharp drills, but I'm trying to focus on the, it's looking a bit better. There, if you look along the lip of the drill there on that flank, there's quite a lot of wear, and if I turn it around to the other one, you can see on the corner there's wear too. So this is a blunt drill, a good candidate for resharpening. I'll measure it. I can't remember what size it is, and we'll use this thing. Okay, so measured it, and it's 9mm or close to 9, so set that to 9mm and then find a colour to suit. Okay, actually it's not too bad that, I'll have a look. Anyway, I've got to put it in here first. Okay, that's it set. That's that one. And that one. And that's much better. That's cleared all the nasties out. And let's put the relief angle on. Got to be a little more careful with this time. That's that one. And that one. And there you see the back relief is on. In this light it's not easy to see, but if I rotate the drill you can see there. Similarly on that one. And it feels really sharp, so let's give it a quick test in the drill, in the machine. Okay, well we'll try some harder material this time. This is a conrod that's buried in that lump of steel, but I don't like the look of it, so I'm just going to drill a hole in here. Now this is EN24, and this is one of the materials. It's very hard, and it's one of the materials that work harden. So if this drill isn't going to work, it'll work harden. But there we see, straight out the sharpener and cutting lovely. And again, it's one curl, but it's also producing stuff from the other side, and you can see it's drilling quite happily without too much pressure. Okay, I'll ease up and take that out, and there you can see there's been cuttings coming out of this flank. I just removed the one. In fact, there you see another there. So it's been cut on two flanks, and also on that flank. It's definitely cutting two flanks at a time, two teeth at a time, whatever you call them. Don't know the terminology, but there you go. So that's how I sharpen my drills. None of this hand sharpening caper. And you know, that really is a nice sharp drill. It's good. It's a typical old drill. It's an old Dormer one. If you expect a drill to stay in one place while you mark, if you mark it out and bring the drill down onto the crossed lines that you've scratched onto the metal surface, the drill will wander off. Now then, first thing to do is where the crosshairs are, or where you've made your mark, make a centre punch mark. And then, once you've got your centre punch mark, use one of these. This is a centre drill. It's used mainly in the lathe for producing a shaped hole, so that you can put what they call a centre in there, dead centre or rotating centre, to support the work in a lathe. But they also are used for spotting hole centres and getting a drill started. See, for instance, this drill here, even this is too small to start that off. I've got one slightly larger, and you know, if you start off a hole, for instance, if you're drilling this size hole, this is a little bit on the larger size. They come in about 5 different sizes, but choose a one that's pretty close to the maximum diameter, the hole you want to produce, and put it in so the whole point's buried and part of the taper, part of the bit is in the metal. Take it out, and then when you drill it, it just forms a nice guide, and your drill will drill where you want it to, rather than you having to chase it all over the place. There are ways to move the centre of a hole when you're drilling it, if it does run off, but again, it's a fussy job, and it takes a lot of practice and skill, and that is just to centre punch one side of the hole and keep centre punching it, and eventually the hole will wander back towards where you want it to. But it's not an easy task. Just a few words about drill bits and sharpening by hand. It is not an easy thing to do. It needs a bit of practice. My advice would be to practice on drills probably about, let's say 8mm or thereabouts, because you can see what you're doing. Once you get down below about 4mm, it's anyone's guess. It's very hitty missy. Sometimes you can get them pretty quickly, other times you can mess on and still not come up with a clean sharp drill. As I say, it just depends upon practice. But the thing is, if you go for a really big drill, yes, you can see clearly what needs sharpening, but they're too heavy, too hefty to handle. There's a kind of technique which you pick up, as I was saying before the battery ran out. With larger drills, they're very heavy, or they can be heavy. I mean, that blacksmith's drill that I showed you is quite a heavy piece of kit. Some of you might not have grinding wheels even big enough to sort of cope with those, or wide enough, but just practice is the way. Stick with the sort of size of drill that you're going to be using. Generally speaking, I think for most motorcycles, you're not needing holes more than usually about 8mm. 5/16 seems to be about the same, most popular size. Certainly on the Humbers it is. Just about every hole's a 5/16 or 8mm. There are a few 10mm and one or two 12mm, and they're the sort of sizes you're going to be using unless you're drilling and tapping. And that's a subject I'll maybe cover in another issue, tapping, how to tap metal without breaking taps. Again, it's another thing, it's practice. If you're clumsy, you're gonna bust taps. So it's very much, like I say, practice with the drills, and you'll get there, and you'll be surprised. Occasionally you get a really sharp one and you think, oh, I'll keep that. Other times you try and eventually grind away to nothing. What started out as a jobber drill becomes a stub drill. So anyway, good luck with the drill sharpening, and let's see some of the results. I.e. broken drills, flat drills, ones that work would be even better with two nice spirals coming out, but no cheating, no going down to the local store and buying a nice new drill and sticking it in a bit of aluminium, getting two lovely curls coming out either flute of the drill. None of that. We'll have genuine stuff. Okay, well, we'll see you again next week.